Good afternoon. This is Rich Nass, Executive Vice President with Open Systems Media and leader of the Embedded Computing Division. I'm here for this week's installment of 5 Minutes With. This week I was speaking to Brad Gaynor, who is the CEO and founder of Lexumo. Good afternoon, Brad. How are you?
Great, thanks. How are you doing?
I'm doing fine. Thank you very much. Okay, so if people aren't familiar, Lexumo is using machine learning to tackle embedded software security. So that's not a subject that's on the tip of everybody's tongue. So first let me ask you, what does that mean exactly? And then explain to me how that works.
So to understand what it means, you have to understand what the security threat is for embedded systems. And you have to see three trends that all converged. Those trends are in embedded systems, all the code is very quickly becoming open source. People grab pieces of open source and stitch it together and race it to market. And the second trend is that cyber attackers go after the path of least resistance. They're going to find the holes that everyone knows about and not look for new ones. And the third trend is that cloud computing enables entirely new solutions to these problems in a scale and a compute capability that never existed before. And so the first two go to the problem, and the third goes to the solution. What we've done at Lexumo is build a graph of all the world's open source software, all the packages, all the versions of them ever, and made that graph searchable.
Okay, hang on. You said all. I mean, we got to be talking billions of lines of code.
Yeah, so we have terabytes of code, and we're ingesting more every day. All is a continuous process in this world. But it's the ability to index and make the code semantically searchable that's really key. The ability to search on a program and find elements of that program everywhere they live.
Okay.
That's the start, but that's not even the machine learning. The second part is the ability to drop into our customers' build systems a plugin that sends the artifacts of their code, not their code, but some representation of their code to our cloud that lets us search and figure out exactly which open source is in their products before the attackers do. You see where we're going with this?
Yep, sure do.
The third piece is figuring out exactly where all of the known vulnerabilities are. And this is where you absolutely need machine learning, because the cloud computing helps with the scale of all the world's open source software, but it doesn't help tie off the knowledge of all of the public disclosures, of all of the vulnerabilities in all of our code to exactly where those live in all of the open source packages. And that's the problem we've solved with machine learning.
Okay, go back into the machine learning then. So how does that work?
So the machine learning allows a team of security analysts to precisely identify exactly where the vulnerabilities in the code are associated with public disclosures. So a public disclosure might look like a CVE, Common Vulnerabilities and Exposures. It might look like a piece of documentation that's maintained in a database. But it won't tell you exactly what's wrong with the code. It won't tell you exactly where the code is broken. The tools we've built use a combination of natural language processing to look at the human-readable inputs for that vulnerability and other graph analytics that examine the code and figure out exactly what's wrong with specific versions of that code, and then trace that vulnerability over all the places in the graph where it exists.
Okay. That's very interesting.
So the end result is by the time we know exactly which open source components our customers are using in their product, we know precisely which vulnerabilities they're affected by. And because this is all done with index search, again going back to the cloud scale, it means if a new vulnerability is discovered tomorrow, our customers hear it from us. We generate an automatic alert. We continuously monitor for new disclosures and are able to propagate that information to the consumers of the code. That's a capability that hasn't existed before.
And that's because they're updating their own code on a constant basis, right?
They could update their code on a constant basis, and we would always be monitoring the latest. Or it could be that HARPBleed 2 comes out tomorrow, and you have organizations around the world scrambling to figure out if they're affected. And our customers would know it from us because we would have taken the single disclosure for that new vulnerability, ingested into our system, run the machine learning, figured out exactly what's wrong with the code and exactly which versions are affected and where, and all of our customers that are using the vulnerable code get an alert.
What's to stop Lexumo from getting hacked?
We have a state-of-the-art security architecture in the cloud. It's designed by people that taught network security to civilians and government in university in the Maryland area. It's a very robust architecture.
Okay. So what would be the first step for somebody? I mean, obviously, it would be you'd want them to contact you, but is there something that they would need to do if they wanted to apply this machine learning?
So we do the heavy lift on the cloud, which means it's very easy to use. Customers would take the build plugin that we've developed, and if they run Make for their embedded code, they would run our plugin in Make, and it's that easy. It extracts all the information we need to figure out exactly which open source they're using, and we've done the heavy lift to figure out where the vulnerabilities are ahead of time. And that's a continuous process, and we continuously update that. So they would continue to get knowledge about that from us.
And why aren't we hearing more about machine learning?
Machine learning is a piece of a solution. So the machine learning is an important piece. It opens up new solutions. But it isn't the whole solution in itself. It wouldn't make sense for us to deploy machine learning to our customers because that wouldn't be solving their pain. Our customers' pain is understanding where their code is vulnerable so they can fix it. So we use the machine learning to close the gap between the human documentation and the actual code. The other thing that the machine learning lets us do is figure out how the open source community has fixed the problems. So we actually look to the versions of code where vulnerabilities are fixed by the open source community, and we extract out using these tools exactly how to fix the code. So not only do we tell our customers where they're vulnerable and how, but we also show them how to fix it. And the machine learning is a key component of that as well.
Very interesting. I'm sure we could talk about this for a much longer time, but as this is a 5 minutes with segment, we've used up our 5 minutes, unfortunately. So I'd like to thank Brad Gaynor. He's the CEO and founder of Lexumo, and I'm Rich Nass with Open Systems Media. I hope you have a great day, Brad.
Thanks. You too.